Hi all. Today we are going to move on with our problem solving series. So in the last video, we discussed a problem statement. To be specific, this problem. We were given an array and we have to find the kth maximum. So let's say this is the array. The first maximum will be, and this is an unsorted array, right? From this unsorted array, we have to find the kth maximum. What we were doing, we were writing a simple algorithm, basically an implementation of the bubble sort to sort the array. Like this is my custom implementation of the bubble sort. And once the array is sorted, let's imagine this is the sorted array. From this sorted array, we know like the last element is the maximum or first maximum. The second last element is second maximum. The third last element is third maximum, and so on. So this is how we were getting it. But can we do better? Because let's say this is the array having random elements. And what we were doing, we were trying to sort the array. And after sorting, it will look like this. -1, 0, 5, 10, and 20. And let's say we have to find the third maximum. So this will be the first maximum. This will be the second maximum. This will be the third maximum. So if we need the third maximum, ideally we should be needing only 3 iterations. The first iteration should be able to give us the first max. The second iteration gives us the second max. And third iteration gives us the third max. Now we should stop at this point of time because we do not need to move any further with sorting the elements of the array, right? This is not required because we have got what we wanted. If k is equal to 3, our objective is attained, right? Let's say if this was an array containing 1000 elements, so we only need 3 iterations, right? 997 iterations will be useless. So how can we improve it? We don't need to sort the whole array. We just need to move until k iterations. For finding the kth maximum, only k iterations are required. That can be done using a different technique. So the idea is to use recursion to achieve it. And we can do that. Let me quickly erase these things. So I'm not going to sort it, and I'm going to use recursion that many number of times. So what is recursion? Recursion is basically one function or method calling itself repeatedly. So if I have a method called my recursive method, this will also help you to get an understanding of recursion. If I call this method repeatedly, one method calling itself again and again, that is basically recursion only. So if I leave it like this, you will get a stack overflow error. Why so? Because this method is calling this method again, and so on, right? We have not specified when to when. So ultimately, at some point of time, memory will overflow and we'll get a stack overflow error. There is no more scope in the stack to keep these variables. So that is a wrong recursive logic. Any recursive logic should have some base condition, which tells us when should the recursion end. So usually the base condition is at the top, but it can be at the bottom as well. So let's say we are passing some parameter. From the main method, I am going to call it once like this. This is the general flow of a recursive strategy, and we are going to soon code it out. Let's say I'm going to call it with some parameter, let's say 10. So this will require some parameter index. So this will be called with 10, right? And let's say I have some logic here. X is equal to x plus 1. So this 10 will become 11. And if I'm calling this repeatedly with x, with the modified x, next time it will be 11. Next time it will be 12 and so on. It will keep going on. Let's say at 20, we want to exit the loop. So we can write the base condition here. If x equal to 20, I can simply say return. Right. So this is how we can write some recursive logic. So this will go on till 10, 11, 12, 13 till 19. This will go on till 19. When it hits 20, this base condition will be hit. If x is equal to 20 will be hit. And we are going to exit this method. So we are going to write a similar logic for it. So what I'm going to do is we're going to write a logic for finding the maximum first of all, right? So if this is the array, very simple logic, let's say called find max. It is going to get the array. That logic is pretty simple. We are going to have some variable called int max. Let's start with the minimum possible value. So the minimum possible value in Java, we can get it by using integer dot min value. That's a constant. This gives the minimum possible value for an integer. Then we are going to loop through it. Int I is equal to 0 to the length minus 1. That is the last index. This will be my for loop. And then what I'm going to do is I'm going to basically check if ARR of I becomes greater than max. In the first case, it's the minimum possible value. So that will be replaced, right? This condition will be true and max will be replaced with ARR of I or ARR of 0. So max will become 20. It started with integer dot minimum value. Now max will become 20. That's it. And this loop will keep running on. Then I will become 1. So max is at 20, right? I will become 1. Then we are going to compare ARR of 1, that is 0 with 20. That's not the case. This condition will not execute. So max will keep moving on like this and like this. In this case, 20 is the largest value, so it's not going to be replaced. And basically, this method can return the max. So if I have the return type as int, after the end of everything, I can return max. So I will get the value of 20, which is the maximum possible value. Now, can we use this logic, this method, find max in a recursive way? Let's say our objective is to generalize it. We are not interested in finding the maximum, right? Our original question was find the kth maximum. This was the original question, find kth maximum, and k can be anything. First maximum, second maximum, third maximum, fourth maximum, and so on and so forth. So if we are able to find the first maximum, we can keep track of some counter, right? This loop has run how many times? So if the counter has run only one time, we have found the maximum or the first maximum. Now we can increment the counter, and next time when this method is recursively called, we can find the second maximum. Right? At that time, the counter will be 2. And then we can find the third maximum. That time, the counter will be 3. So whenever this counter hits k, let's say k is equal to 3. So at that point of time, we can exit, and whatever is the maximum value, that is the kth maximum, right? So in this case, if I have to find the second maximum, the counter will run 2 times. Second maximum is 10. If I have to find the third maximum is 5. So in a way, we can use that. We'll have to modify these parameters, what needs to be passed here and what needs to be done. But that is the logic that we are going to write. We are going to write a recursive logic and use the find maximum to run it that many number of times, depending upon the value of k. Let me get to the code part. So this is what we did in the previous video, where we are simply going to sort it. And after sorting it, I have the sorted array. From the sorted array, I can easily find whatever kth maximum I want to find. But so as to improve the efficiency, we don't want to sort the whole array. We are going to write a recursive logic for it. What I'm going to do is I'm going to modify this program itself right here. Let's delete the necessary parts. Comments can be deleted. And I'm going to not have this sort method. So that goes out. Let's keep it simple. I'm going to write a method called find kth max. Let's have some static variables, static int k that is given to us. So if the array is sorted, it would look like -1, 0, 5, 10, and 40. And if k is 3, the answer should be what? I'm interested in finding the third maximum, so right in the middle. So in that case, the answer should be 5. Let's have this as the test case. So these are all static things. I don't need to pass it here. In the kth maximum, let's write the method for it first. Static void main, and here I'm going to call a method called, let's call get max. I'm going to pass it some attribute. Let's create it right here, public void get max. For time being, let it be void, and then we'll fix it. So how do we get the max? This was the original logic to get the max. We need the minimum possible value inside max. So that can be done by using integer dot, the wrapper class in Java has that min value. Then I'm going to loop it through for 0 till the last index, which is length -1. This is static that I can directly access, and then less than symbol, so that will take care of length -1, and then I++. If the max equal to not equal to but greater, in fact this is a better approach, ARR of I is greater than max, then I have to update the max. Otherwise I don't have to do anything, and this loop will take care of itself. Let's try to print it out for, let's try to return this. And I'm going to get the max here. It requires a static method, so let's make it static, public static. That's because the main method is a static context, and from a static context we can only call another static context. From a static context we cannot call a non-static context. I'm just trying to quickly see if I am able to get the maximum value. So in this case, the maximum value is 40. And that is what I'm going to quickly test. And I'm getting 40. So I'm getting the maximum. Now I have to modify the logic in a recursive way. Right. So what can we do? So the first thing that I need is some kind of counter, right? Some kind of counter that is needed here. So in this method itself, I'm going to have, and we also need, let's keep the counter first in counter. We also need to keep track of what is the maximum, right? Because if we are able to, let's say in this same problem statement, 20, 0, 10, -1, 5. So this is how my approach is going to be. These are the indices. When this find max runs for the first time, I would be getting the value what? The first maximum. The first maximum would be 20. And then I'll compare, is this first maximum equal to the value of k? Let's say the value of k is 3. So first maximum is not good enough. I want to move to the second maximum, right? And since the value of k is 3, I will later on move to the value of the third maximum. But when I'm calculating the second maximum, I have to work in place, right? I have to work in such a way that I get rid of the first maximum. So I don't have to consider thinking about this value. I've got the first maximum, right? When this recursive logic will run, it will find the maximum. So now it should find the maximum among the remaining elements. This subset, 20 should be taken out of the list. That is the requirement. So since I'm working with the array in place, what I can do, I'm going to use the same array, right? The same array is going to be used. I'm going to pass some, what should I say? I'm going to pass some kind of skip index, so that when this recursive logic runs for the second time, it does not take care of the 0 index. So this is the first maximum 20. The index for this first maximum is 0. So I'll also need the index. And then when I'm calling it for the second time, this recursive logic, I should not compare any value with this index, so that this is taken out of the picture. I'm only comparing among the remaining set of elements. In this remaining set of elements, the second max, I need the maximum, right? This method will return me the maximum. So the maximum will be 10 in this case, right? 10 in this case. So second maximum will be 10, which is present at the index 2. And now, how many times this loop has run, right? This index k is equal to 3, but the counter is equal to 1 to begin with. I have to increment the counter. Counter becomes 2. Is 2 equal to 3? No, that's not the case. So we have to keep going, right? So we'll have to run this recursive logic one more time. And again, when I'm running it, 10 is already the maximum in the previous iteration. So I have to not consider it. So now I'm only considering among the remaining elements, these 3 guys. Among these 3 guys, what is the maximum? This recursive logic will kicking again, and third maximum I'll find. Third maximum is nothing but 5, which is present at index 4. And I'll increment the counter to 3. And now when this loop will run, this 3 is equal to k. So that is the point we need to stop. So whatever is the maximum at that point of time, which in this case 5 is the maximum present at the index 4. So the answer should be 5, right? This is the answer 5. And now this is the time to stop. How do we codify it? Like, what is the time to stop? Basically, we have to codify it by specifying some condition here, that if the counter value equal to k, that is our base condition. We can return here itself. Return the maximum that we have calculated or computed at that point of time. Otherwise, we will keep calling recursively the find maximum method. And now I think you should be able to guess what should be the parameters that should go inside the find maximum. First of all, we don't need this array because we are maintaining a static global list. Remember, in the code, we have a static array list. So what we need is basically the counter, because we have to increment the counter one by one. And we also need the maximum, right? We also need the maximum, because ultimately when we have found the maximum, we should have it present inside the method. Then only we can return it back to the original main method. We need the counter, we need the max, and we also need the skip index. One small thing I want to clarify right here. So when we were finding the third maximum, when we were finding the second maximum, like this one, when we were finding the second maximum, we skipped whatever was the skip index that we found from the previous one, right? So when you're finding the second maximum, like here, the skip index was 0 because in the previous iteration, 20 was the maximum and its index was 0. So next time it should skip 0. But then when we were finding the third maximum, like among these three things, remember we not only have to skip this 2 as well as 0. So it's like not one skip index, but multiple skip indices. If I'm at the nth iteration, all previous iterations, 0 to n minus 1 iterations, for all of these iterations, whatever was the maximum found at whatever indices, all those indices need to be skipped. That is how the recursive logic will operate. So it's not one single skip index, it will be a list of integers. That is how we are going to modify the parameter, list of integers. It will become a little more clear when I code it out. And since it's a list, let's call it plural skip indices. So these are the three parameters that we need to pass inside the recursive logic. Let's codify it. I need, first of all, let's have the max and then the counter, and I need an array list, right? So let's have a polymorphic reference. A list type can store an array list object. Let's call it skip indices. For the first time, and then when this method is called, I need to pass the maximum and then, okay. So let's have the smallest possible value as the maximum, so that this is the same logic. We start with the starting value of maximum as the smallest possible value. So when I'm calling this method for the first time, this recursive method for the first time, called from inside the main method for the first time, I'm passing in integer dot min value that will corresponding to max. Counter basically keeps track of, if I'm finding the kth maximum, is the counter equal to 1, 2, 3? That is how we keep track. So we can begin the counter with -1. When we have found the first maximum, we can initially say 0. Counter can become with 0. When we have found the first maximum, counter would have been incremented to 1. So whatever is the value of counter at any point of time, that will tell us how many iterations we have covered already. If counter is 0, we are yet to find the first maximum. If counter is 1, we have already found the first maximum and now we are searching for the second maximum. If counter is 2, we have already found the second maximum and we are searching for the third maximum. If counter is 3, we have found the third maximum. And if k is 3, we have reached our answer, we have to return. So that variable is keeping track of the number of iterations. And we also need the skip index. So let's pass an empty array list here. Array list of integer. And we are going to it's a new array list, right? We have to create an array list object. Some brackets. Now it's fixed. An empty array list is there that is captured inside this parameter. And now I can write some logic. So let's write from scratch. What can go here? So first of all, I will write my conventional loop for getting the maximum. It will start from I is equal to 0. It will go on till ar.length and I plus plus. And if arr of I becomes greater than max, in that case, I have to update, right? Max has to be updated with arr of I. And remember, we need to keep track of what index is the maximum. Remember, once I have found that 20 is the maximum, I need the index as well, 0, so that I can skip it in the next iteration. That will be useful for populating the skip indices. So let's keep track of the index as well. So let's call it max index. Max index will be I. And let's declare it here. Int max index. To begin with, let's have an index that is -1, 1 less than the 0th index. So it will get updated with whatever is found. The maximum for the first time, its corresponding index will update this value. Cool. So now this loop will recursively run, but we have to return something. So let's call it, this is the recursive call to get maximum. So every time we are going to reinitialize this max variable with the minimum possible value, because every fresh iteration, we have to see that the previous iterations, the previous max, whatever was the max, that should have been overwritten. So the first time I'm going to call it with integer.min value, and then I'm going to reinitialize it. Let's call it integer.min value. And then I need to pass the counter that keeps track of how many iterations we have already covered. And remember, we need to pass in the skip indices list, because when I'm calculating the second maximum, right, this should not be compared. When I'm calculating the third maximum, all previous indices, that is 0 and 2, that should not be compared. So skip index list needs to be maintained here. I have to add it something to the list. Right now it's empty, but I will keep passing it here. And the updated list is getting passed on to the next iterative, to the next recursive call. And then what I can do is, remember, we have to use the skip index list, right? So we are basically using the skip index list to skip certain iterations. Whenever, let me write it down and then it will become clear. So if skip indices dot contains, if it contains I, so this loop will run, and whatever is the current value of I while I'm running this for loop, if the skip index is containing that value of I, that means we don't have to compare it. So basically I have to skip that iteration and move on. So the keyword that comes to the mind is the continue keyword. It's a classical use case scenario. We can continue the loop. We don't need this logic to get executed immediately, but we need the rest of the loop to be executed. So if in this case, we already found the first maximum, which is 20. So when I'm trying to find the second maximum, of course, the loop is going to run from 0 only, but because of my logic, now it is going to skip this 0th index, and the calculations will start from index 1 onward. Similarly, let's say if I'm trying to find the third maximum, first maximum is 10, second maximum is 10, and I'm trying to find the third maximum. So while trying to find the third maximum, the array is the same, so I have to skip 0 and 2. So the skip index should not contain, if the skip index contains 0 or skip index contains 2, I have to skip this 0 and 2 indices. That is what I'm trying to write. If skip indices that contains I have to continue this external loop. Otherwise, I can move on. And that's it. I think this is good enough. Max index is started with 1, and then we're trying to run the loop. And if the skip index is containing any of the I values that is present at this point of time, then I'm skipping this iteration and continuing with the rest of the iterations. But where am I adding to the skip index, right? Skip index is all empty as of now. So I have to write that logic as well. What I can do is I can write it outside the loop. Here is a good time. So I have already found the maximum. I've got the max index. So skip index is basically going to be the skip indices, not index, plural. That's an array list. So I can add to the array list, and I can add the max index to the array list. So that is how we are populating the skip index list every time we are running this recursive method. Also, we need to increment counter, right? So that keeps track of how many iterations have been covered. So counter started with a value of 0. When this much has been run, I have found the first maximum. So I can say counter is equal to counter plus 1, which means first maximum is already found. In the second call to this method, counter will be 2, which means that second maximum has been called. At some point of time, I have to see that if is the counter equal to, that is basically the exit condition or the base condition. If counter equal to k, that means I have reached my goal. My intention was to find the kth maximum, and if counter has reached kth, it means this recursive method has been called that many number of times. So now is the time to simply exit the recursive call. So whatever the maximum, whatever the value of max, right? This is the value of max. I can simply return it, and that will be the kth maximum. Okay, let's call it skip indices list just to be more explicit. In IntelliJ, I have this option to refactor and rename so that I don't have to manually rename each and every occurrence. I can directly say this and it gets renamed. Let's try to see. Our k is 3, so answer should be 5. Third maximum is 5 only. Let's see what we get. Right, third maximum we're getting 5. If I wanted the second maximum, so second maximum is 10, answer should be 10. And let's see, we're getting 10. If I want to find the maximum, right, first maximum or the maximum, so in that case answer should be 40. And let's see, right, we're getting it. So this is how you can improve the runtime complexity. There are several ways of solving this question. Find kth maximum in an unsorted array. The easiest approach is to sort it out. Then we have to, then you're basically sorting the whole array. That is an easy way, but does not have good runtime complexity. So as to improve or optimize our code, 2 other techniques can be used. We can use a max heap. We can use some quick select version. These are the other approaches. And this specific approach also we can use. We are not doing anything here. We are just using recursion to allow us to not to sort the whole array, but if we are trying to find the third maximum, only 3 iterations we are covering. So this will have a good performance in average case. If the size of the, let's say we are trying to find the maximum. So this whole logic will run only once. If I'm trying to find second maximum, the whole logic will run twice. If I'm finding the third maximum, the whole logic will run thrice. So if this is an array of 1000 elements and I want third maximum, I don't need 100 calls, or I don't need, if this was an array of 100 elements, according to this logic, sorting the whole array, I would be needing 100 calls. But if I'm finding the third maximum in an array of 100 elements, only 3 calls are good enough, because at the third instance, the exit condition will kick in and that's it. So I hope you enjoyed this video. This improves the runtime complexity, and in the later videos, we are going to see what all other approaches are there. If you like this video, please subscribe to our channel. It is zboard.com. That's the website we are having. And here you can get different kinds of videos related to software development, web development, full stack development, problem solving using different kinds of collections and data structures, interview preparation, and so on. So please like and subscribe our channel, and do visit this website zboard.com for further updates. And for any queries, please feel free to contact at the email and the contact numbers mentioned at the website address. Thanks for watching and have a nice day.